Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of arrays with k matching adjacent elements. Now the problem category is of hard level, but I would say you just need to understand the maths behind this problem, and this is going to be not easy but super easy to solve. You just need to know about the maths of this problem. In this video, I am going to explain you everything which requires to understand the mathematics of this problem, and once you watch this video completely, this problem will be super easy for you. The given input in this problem is three integers. So we are given total three integers and the integers are n, m and k. Let us say the integers are n, m and k. The output which we need to give in the problem is return the number of good arrays of size n. This n is given in the input. So we need to return the number of good arrays we can create of the given size n. Now we need to understand what is a good array, right? So a good array of size n is that array in which each element in the array is in the range of 1 to m. Now this is the first condition. If you want to create a good array of size n, then each element in the array will be in the range of 1 to m. This m is given in the input as well. So we need to create a good array of size n. A good array of size n will be that array in which each element is going to be in the range of 1 to m. This m is given in the input. The second point is exactly k indexes in the array will have this condition as true. The condition is ARR of I minus 1 will be equal to ARR of I. That is, for any given index, let's say the index is 1. At index 1, if the element is 5, then at index number 0, the element is going to be 5. Now this is one pair, or you can say this is valid for one index. So you need to have total k indexes for which ARR of I minus 1 will be equal to ARR of I. That is, adjacent elements in the array will be equal. So again, I'm going to tell you what is a good array. A good array is of size n when each element in the array is in the range of 1 to m. M is given in the input and it will have total k indexes, or I would say total k number of places at which adjacent elements are equal. That is, ARR of I minus 1 will be equal to ARR of I. Now the answer can be too large. The answer is the number of arrays, the number of good arrays of size n. Now this output or the answer can be too large. So we need to return the answer, whatever the number of arrays we can create, mod 10 is to power 9 plus 7. This is what the question says. Now this k, m and n, all these three are given in the input, and now let us try to understand this particular question with an example. In the example, the given value of n is 4, so we need to create a good array of size 4. That is, it will have 4 elements. The indexes are going to be 0, 1, 2, 3. Total 4 elements, and these are the indexes. The given value of m is 2. It means all the elements in the good array is going to be in the range of 1 to 2. This 2 is the m. It means all the elements in the array will be either 1 or 2. That's the range we have, right? And k is equal to 2. It means that we will have total 2 adjacent pairs in the array in which the elements are going to be equal. Or we can say there will be 2 indexes in the array for which ARR of I will be equal to ARR of I minus 1. This ARR means our array. Now for this given set of input, the output is 6. It means we have total 6 number of good arrays of size n, and the elements in the array will be either 1 or 2 because the range is from 1 to m is 2, and there will be exactly 2 indexes, or I can say exactly 2 pairs of adjacent elements. Those are going to be equal. Now let us see what are those 6 good arrays. The indexes are going to be 0, 1, 2, 3. The array is going to be 1, 1, 1, then 2. This is the first array we have. Now let me try to prove that this is a good array. This is of size n, right? It has 4 elements, so it is the size of n array. Then we have elements as 1 or 2. That's the range we have from 1 to m, that is from 1 to 2. So the elements are 1 and 2. The next condition is there will be exactly 2 indexes for which ARR of I will be equal to ARR of I minus 1. Or I can say there will be exactly 2 number of adjacent paired elements. Those are going to be equal. So I can say the indexes are, for this first array, the indexes are 1 and 2. That's because for the index 1 and index 0, the elements are equal, right? 1 and 1. For index 2 and index 1, so if I say I is equal to 2, so I minus 1 will be equal to 1. So the indexes 2 and indexes 1, the elements are 1 and 1. So they are equal. Or I can say there is exactly 2 number of adjacent elements pair. Those are equal. So this is the first pair we have. These are the 2 adjacent elements and they are equal. And this is the second pair we have. These are the adjacent elements and they are equal. So we have exactly 2 adjacent elements or 2 adjacent pair elements which are equal. In the second array, this is our second array. They are again going to have 4 elements. So n is equal to 4 and the number of elements in the array is 4. 1, 2, 3, 4. The elements are 1 or 2, right? 1 or 2. That's the range we have. And there are exactly 2 pairs. So this is the first pair of adjacent element and this is the second pair of adjacent elements which are equal. In the third array, this is the first pair, this is the second pair. In the fourth array, this is the first pair and this is the second pair. In the fifth array, this is the first pair and this is the second pair. And in the sixth array, this is the first and this is the second pair. So these are the 6 number of good arrays we can create when the given set of input is 4, 2 and 2, the value of n, m and k. Now let us try to understand how can we solve this question using purely mathematics. Now let me try to explain you one very important thing. We will come to this value of m, but first of all we need to try to understand the second condition, which is for k indexes or for k adjacent elements, the elements are going to be equal. Whatever the value of k is given, let us forget about it. Let us just purely focus on what is the value of n. The value of n is 4. It means we are going to have exactly 4 elements in our array. And let us say the indexes are 0, 1, 2, 3. Now the question says that we want exactly 2 adjacent pairs to be equal. First of all, tell me, if the array is of length 4, how many adjacent pairs do you have? Is the number fixed? Do you exactly know how many adjacent pairs you will have? Yes. If we know the size of the array, if the size of the array is 4, that is n, then we will have exactly n minus 1 adjacent pairs. And let me show you how. If this is your array, if these are the indexes 0, 1, 2, 3, the size is 4, it means we are going to have exactly 3 number of adjacent pairs. This is the first, this is the second, and this is the third. And that is always going to be the case. That is, I can put a line here, and these two elements are going to be adjacent. I can put a line here, and these two elements are going to be adjacent. And I can put a line here, and these two elements are going to be adjacent. Or I can say they will form a pair. So I can say the total number of pairs I can form for a given value of n, that is the size of our array, is n minus 1. These are the total number of pairs we can create, and this will not be different, this will be same. So I will be talking about same pairs. Now the total number of same pairs, that is same valued pairs, should be k, right? The question says that we need exactly k number of pairs or k number of adjacent element pairs in which the elements will be same. That is, they will be 1 1 or 2 2 or 3 3, something like that. So again let me tell you, if the given size of array is n, the number of pairs you can form, the number of adjacent element pairs you can form is n minus 1, and we need that total number of adjacent element pairs for which the elements need to be same are k. So there are total k positions, 1, 2, 3. We have 3 number of k positions, that is 3 number of places where I can say it forms a pair, 1, 2 and 3, right? So there are total number of k positions to choose out of n minus 1 positions where the elements can be same. That is, if we have total n minus 1 positions to choose, 1, 2, 3 or whatever is the number based on the value of n, we have total number of adjacent pairs available are n minus 1, and we need to choose total number of k pairs, k adjacent pairs out of it in which the elements are going to be same. And that's what it's written here, that there are total k positions we need to choose out of n minus 1 positions where the elements can be same. This is the basic formula of combinations in mathematics. We need to choose k elements out of n minus 1 elements. So the formula is n minus 1 c k. N minus 1 is the total number of data we have, k is the total number of data we need to choose out of n minus 1. So the formula is of combinations from mathematics. N minus 1 c k. That's the formula we have. So now we can basically choose k number of positions out of n minus 1 positions, and we can keep the elements same. That is, the elements whatever we choose out of the range of 1 to m, we can choose to keep the elements same at these number of positions, right? Now let us try to understand the next thing. Now we need to put the elements, right? The elements which we have from the range of 1 to m. Now we have m different numbers from the range of 1 to m to create the array, right? We need to create the array, and we have total m different numbers to choose from. That's the range 1 to m, and we need to create our array. Now the first thing which you need to understand is, at the first position of your array, at the index number 0, at the first position, you do not have any restriction. You can choose any element which is within your range, 1 or 2. That's the range you have, right? If the value of m is 2, the number of elements you have is 1 and 2, right? That is total m number of elements. At the first position, you have no restriction because before the first position, you don't have any element. So at the first position, I can keep any of the elements out of the m elements which we have. So I would say the number of elements we can have at the first position at ARR of 0, that's the first position, is m. So now our formula is m multiplied by n minus 1 ck. This n minus 1 ck is exactly what we have here. That is, how can we choose k different adjacent positions out of n minus 1 positions. Now we need to try to fill the element. At the first position, I will try to fill m different number of elements. Now what about the other positions? Now let us try to understand it. We have k adjacent elements that are same, right? That's the thing we know. And we have total number of adjacent elements as n minus 1. These are the total number of adjacent pairs we have, n minus 1 pairs. Out of this n minus 1 pairs, k adjacent pairs elements are going to be same, right? So the number of elements which remains is n minus 1 minus k. That's n minus k minus 1. Now these are the adjacent pair elements which will not be same. Now try to understand it. If you have this array, that is, these are the indexes of your array, and you have two different positions or two different adjacent elements pairs, that is one pair or two pair, So you have two pairs at which you can keep the elements same. So you have total n minus 1 minus k number of pairs at which you need to keep the elements different. Now let us talk about how can we keep the elements different. Now let us say if I keep this element as 1 and I want to make this particular pair different, then how many different elements I can put at this position, the position number 1, the index number 1. That will be m minus 1. Let us say the value of m is 5. I have 5 different numbers to choose, 1, 2, 3, 4 and 5. If I make this element as 1 at any index, let us say the index is I, then for the next index, if I want to make this particular pair different, then I will have 4 different options to choose for this position. That will be 2, 3, 4 and 5. I cannot choose one because that will make this particular pair equal. So the thing is, I want to make this pair unequal or different, then I have total m minus 1 elements to fill. Now let us come back to this. We have total n minus 1 adjacent pair elements. Out of that, k adjacent pair elements are going to be same. So n minus 1 minus k number of adjacent elements will not be same. And we have total m minus 1 elements which we can fill at these positions. The number of positions are n minus k minus 1 and the number of elements we can fill at those positions are m minus 1. So the formula is going to be for other positions as if we have these number of positions, so the formula is going to be m minus 1 to the power n minus 1 minus k or n minus k minus 1. So the final formula to fill all the values at different positions is going to be n minus 1 c k. That's the different number of adjacent pairs we can choose at which k number of positions are going to be same, multiplied by m, that's the element which we are going to fill at the first index, multiplied by m minus 1 to the power n minus k minus 1. This is for the number of adjacent pairs we have which are different, for which the elements are different. So this is going to be the final formula for this particular problem, and that's it. That's what we need to do. And that is why I told you guys that this question is not about being hard. This question is about being super easy. You just need to know the mathematics behind it. Now let me take you back to the code editor and let me try to explain you the code, and the code is of just 4 to 5 lines, and that is going to be super easy to understand. Now this is the complete code we have for this particular problem. First thing is the mod, which is equal to 10 is to power 9 plus 7, because the answer can be very large, so we need to return it with modulo of 10 is to power 9 plus 7. Then we need to calculate the value of comb, which is equal to math.combinations or math.comb n minus 1 comma k. This is going to calculate the value of n minus 1 c k. That's the number of combinations we have of k different adjacent pairs out of given n minus 1 pairs, for which the value is going to be equal. Then we calculate the power value, which is equal to power POW, in which m minus 1 to the power n minus 1 minus k is calculated. And this is for the remaining n minus 1 minus k positions, adjacent positions, for which the elements are going to be different. We also pass the value of mod here so that the power can be calculated without any memory issue. Basically what it does is whenever it calculates the power, it takes the mod of it. So the number is never very large. And then what we return is the comb, that is n minus 1 ck multiplied by m, that's the first position we have, and then multiplied by the power, which is n minus 1 minus k number of adjacent pairs we have. The total of this will be modded with mod, and that's the complete code. You can just submit this code and this is going to pass all the test cases, and this is going to be super efficient for this particular problem. You can see the runtime is good, the memory used is good. So this particular solution is very efficient for this particular problem. So we have solved this particular problem, and I think that's it for this video, guys. If this video helps you to understand the problem, the mathematics behind this, and it helps you to solve this particular problem, then make sure that you hit that like button. And if you have not subscribed to the channel, then make sure that you subscribe to the channel as well, because it takes a ton of efforts to create videos like this. And you can check out my channel. I have a lot of Leetcode questions which are solved on this channel. And apart from Leetcode, there are other videos as well which can be helpful for you. So this is just a genuine request from you guys to appreciate the efforts which I put in the video, and make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.